Okay, today we will be learning to calculate the length of a line in the coordinate plane. And as you can see on my illustration here, I have three lines. I have line A, line B, and line C. And I have labeled their coordinates. For example, line A, the left coordinate endpoint is -3, 5. And the right coordinate endpoint is 7, 5. So, how can we calculate, using these coordinate endpoints, how can we calculate the length of the line? Well, let's look at our guidelines here. All right, notice the length of the horizontal line segment is equal to the positive difference of the x-coordinates of its endpoints. So the positive difference of the x-coordinates of its endpoints. Well, that word difference means subtraction, doesn't it? All right, a problem might look like this. Find the length of line segment A. Okay, so the difference between its endpoints. All right, and we're looking at its x-coordinates. So here we would have 7 and we would have -3. So I would take 7, take away, that's difference, -3. All right, when you see a double negative, that's take away the negative, and so that equals 7 plus 3, which equals 10. Okay, that's the math for it. Let's check it out just looking at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it does work out. Okay, well, what about a vertical line? Okay, the length of the vertical line segment equals the positive difference of the y-coordinate endpoints. Okay, notice line B is vertical. Find the length of the line segment B. Okay, well, we're going to take our y-coordinates now. Remember, the y-coordinate is the right-hand coordinate in the parentheses. So we have a 7, and we find the difference, so take away. And what do we have here? We have -6. So take away -6. And let's do the math. Take away the negative, so that equals 7 plus 6. So that equals 13. Well, let's count it out and see if it really did work out that way. Starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, it did work out, so the formula is a good formula to use. All right, we have a third line here. Look, notice line C is diagonal. What are we going to do with that? Well, I want to remind you of a math theorem. It's called the Pythagorean theorem, and we can apply that theorem for a diagonal line. The Pythagorean theorem says a squared plus b squared equals c squared for a right triangle only. Okay, so what does that mean? Well, if you see, I can kind of see a right triangle here. Here would be one side, here would be another side, and then the diagonal line. So you do see the triangle. Now, we could call this side A, we could call this side B, and we could call this side C for the Pythagorean theorem. All right, well, let's look. This point here, it's 1, 2, 3, 4, 5, 6, 7, 8. So we're going to use the y-coordinate. So side A equals 8. And then side B, 1, 2, 3, 4, 5, 6, 7, 8. And that's the x-coordinate. So B also equals 8. And we know the formula. So the formula is A squared plus b squared equals c squared. All right, so a squared plus b, let me write an 8 in there. I'm putting in my amounts for my variable. Squared equals c squared. Okay, 8 times 8 is 64, plus 8 times 8 is 64 equals c squared. Okay, so that would be 128 equals c squared. Well, to get just c, in other words, we need c instead of c squared because we want to know the length of c. So to get c alone, we could find the square root of c. So the square root of c squared, not c, c squared. Okay, we want the square root of c squared with that equals the square root of 128. So we can find c that way by square rooting c squared, which would be c, and square rooting 128, which is not popping in my head right away. So I think I'm going to use a calculator. 128 square rooted. Okay, and what do I get? I get a decimal, 11.313708. So I get 11.313708. Well, that's a big number. I think I'll just round it. C is about 11.3. Okay, so this is the kind of math we'll do for finding lengths of vertical lines, horizontal lines, and diagonal lines. Let's try some practice problems.